The new chapter in GCMS history. More than a century ago, in 1903, a brilliant chemist by the name of Michael Tzvet came up with a way to explore mixtures of chemical compounds. He did so, oddly enough, in his attempt at analyzing plant pigments. It was there that early column chromatography was born. Meanwhile, partway around the world, an English scientist by the name of J.J. Thomson figured out how to tell two isotopes of neon apart using a technique called mass spectrometry. And in 1919, Thomson's student, Francis William Aston, developed the first mass spectrometer, allowing scientists to identify compounds using mass-to-charge ratio, for which he etched his place in history, winning the Nobel Prize in Chemistry in 1922. Fast forward to 1949, British scientists Anthony James and Archer Martin started to develop gas chromatography. This happened after Martin had already laid down the principles of partition chromatography almost a decade earlier with another British scientist, Richard Synge. Martin and Synge went on to win the Nobel Prize in Chemistry in 1952. Scientists tried coupling gas chromatography to mass spectrometry, but the combination only began to produce real data after Roland Golka and Fred McLafferty combined GC with a time-of-flight mass spectrometer in the early 50s. Meanwhile, around the same time, Joseph Holmes and Frank Morel combined GC with magnetic sector instruments. This instrumentation allowed them to both separate a sample into its compounds and then investigate the identity of said compounds based on their makeup. Then, in the 1960s, Robert Finnegan of Finnegan Instrument Corp began to sell the combined GCMS instruments to laboratories at Stanford and Purdue universities. As one would expect, GCMS instruments became more advanced over time. Through the 60s and 70s, gas chromatographs were coupled to a variety of different types of mass spectrometers, including quadrupoles, ion traps, and time-of-flight instruments, which each provided different levels of performance. And in 1970, computer algorithms were introduced to identify compounds by comparing their spectral data to that of known compounds. An explosion in scientific research in multiple fields followed, fueling even greater developments. Now, on to one of the biggest breakthroughs in GCMS technology to date. In the 1990s, Thermo Fisher Scientific's own Alexander Makarov developed the ORBITRAP-based mass spectrometer. When it was coupled to liquid chromatography, these LC-MS systems quickly revolutionized the industry through their truly outstanding ability to aid the discovery, identification, and quantitation of compounds. Not surprisingly, a lot of people started asking about creating a GC ORBITRAP instrument. In fact, they asked a lot. Well, really, they demanded, and we listened. Thermo Fisher Scientific started a research collaboration with Joshua Kuhn and his co-workers at the University of Wisconsin to explore the potential of such a device. A truly international collection of technology was brought together from Milan, Italy, Austin, Texas, San Jose, California, and Bremen, Germany. Then, in 2010, the Kuhn Lab, along with scientists from Thermo Fisher Scientific, published the very first paper on GC ORBITRAP technology in analytical chemistry. This work sparked a new project to build the world's most anticipated GCMS system, leading us to the beginning of a whole new chapter in GCMS history, with the introduction of the Q-Exactive GC Hybrid Quadrupole ORBITRAP Mass Spectrometer. Today, the page is blank, ready to be filled. We're incredibly excited to see what you write.